the basics of law of sines, which I know that all of you guys have seen before. We use, like we've been getting at here, we've talked about right triangle trig, we've talked about elevation depression, we did a little bit of that, find the missing, or find the different theta values given certain parts of trig functions. The last couple of bits before we kind of get away from using calculators is going to deal with law of sines and law of cosines. Now, I know that you guys have all seen both of them. What's going to be a little bit different is what we're going to call an ambiguous case, which I think you might have heard about before, where it's possibilities of not making a triangle, possibilities of having multiple triangles, things of that nature. What do you do to figure that part out using law of sines? Because once you see law of sines, you'll be like, oh yeah, I remember that. So law of sines was that whole idea of in a non-right triangle. What's that? Yeah, you did it last year.
Trig? I thought trig was so easy.
So law of sines is for when you have an angle and its side opposite. We use law of sines when you know an angle and a side opposite. So remember, capital letters are vertices, lowercase letters are your sides. And we use law of sines whenever you know an angle and its side opposite. And what you wind up with here is ratios, where you say the sine of angle A is to its side opposite, is the sine of angle B is to its side opposite. The sine of angle C is to its side opposite. Okay. Now obviously you're not going to be solving for all 6 possibilities at one time. What you're going to be doing is you're always, whenever you use law of sines, you're always going to reuse the given values of an angle and its side opposite to therefore be able to figure out the other parts, whether it's going to be a missing angle or a missing side length, and then you just build out of that. Okay? Because what happens is, worst case scenario is that you have to use the law of sines twice. Because usually then you'll know 2 angles, you know that there's 180 degrees in a triangle, you can find that third angle and do things like that. But one thing I do want to remind you guys, when we get to law of sines, is that you kind of have to make sure that you're very cautious with how you set things up. And be careful in how you press the buttons on the calculator, because when you're finding angles, there's different sequences and things like that. So what happens here is that we're going to use the law of sines for when you have 2 angles and any side, or you're going to use it for when you have 2 sides and any angle. So this is when you think back to the ideas of, angle, angle, side, angle, side, things like that. The use of law of sines is the only time you can say that there's ass in math, because you have an angle, side, side. Remember that? So what I want you just to think of is that you don't need to worry so much about the specific titles of each one of these. If you have an angle and its side opposite, use law of sines. If you don't, you have to use law of cosines. That's as easy as this gets. Don't worry about the specific cases. If it's an angle, all you need to worry about, if you have So whenever I have these types of problems, you'll always see me do this. As I draw out my pictures, you'll see me say, hey, look, I've got b and little b. I will circle that, and then what I do is I use that as, I kind of call it a pivot, I use that to solve for the other parts. So I just continually reuse the given information to figure out the other pieces of the triangle, okay? And like I said, these wind up being, two-step equations, and just remembering that the sign of an angle is just some crummy decimal, and work from there, okay? I'll show you an example. Solve triangle ABC with angle C at 103, angle B at 28, little b at 26. What do you think I'm going to suggest that you do first? Draw a picture. Always. Draw a picture.
Not drawn to scale.
Exactly. Thank you. Not drawn to scale. So what happens here right away is that you will see that you do have an angle and its side opposite. Which angle and side opposite do we have? B. Good. You'll see that you have this right away. So once you get that, what I'd like you guys to do is then list what parts you need to find. Well, do I have to find any angles? Okay. It means I have to find angle A. I have to find little a, and I have to find little c. By putting that off to the side, it will remind me, oh, I have to do three things. I know that you guys get in that one-track mind of just getting the problems done as fast as humanly possible because math sucks, but by writing that down, three things, you'll know that you'll have to do three things that you don't want to do. Right? It just forces you to remember what you have to get to. So, of those three things that you don't want to do, what's the easiest one to find? A, because all the angles in the triangle have to add up to 180. So take 180, subtract out the 103, you're left with 77. Subtract out the 28, and you're left with, was it 49? Bless you. So we have 49 here for A. Now I'm going to use the law of sines to find the missing side lines. I'm going to do it twice, because I have to. So I can say that the sine of B, 28, is to 26, its side opposite, is to the sine of 103, is to little c for its side opposite. When you have fraction equal fraction, what do? Cross multiply. Now, there will be a shortcut that you'll probably pick up on here after you do a couple of these, but I'm going to write it out long form just to start out with. I'm going to get c sine 28 is 26 sine 103, and then just divide it out. Please, 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 write down what you're going to put into your calculator before you put it in your calculator. Especially with law sines and law cosines. There are too many numbers, there are too many things, there's too many accidental ways of screwing something up. Because if you screw one of these up, it's so fast to screw up all of them. But if you have things written down, I can figure out where you went wrong, and I can tell whether or not you really do know what you're doing, or you're just making stuff up. Mode, make sure you're in degree mode. So 26 sine 103 divided by the sine of 28 and hit enter. I'm getting 5396. Okay. Oops. All right. So I get 5396 for that. And now I do that again to figure out side A, I believe, right? I do it again. So we have the sine of 28 is to 26. Is the sine, oh, it was 47 or 49?
49.
Thank you.
No,
Okay. And I do the exact same thing. And notice, is my variable in the same spot? So can I just get away with just saying, hey, B is gonna equal 26 sine 49 over the sine 28? Because I'm just moving these, all I'm changing is that number. A lot of times as you start doing these things, if you're doing it multiple times, you can get away with doing some of the shortcuts and showing it a little bit less work. It's fine. Type it again, 26 sine 49, enter. Sine 028, 41.8. And now I put it back together by my triangle to see if it makes any sense. And what I mean by checking to see if it makes any sense is when you had Pythagorean theorem, when you had right triangles, you could always verify if your side lengths and everything were correct because the Pythagorean theorem would hold true. You guys agree on that? With this, it's hard to do. Really, all you can do is just try to see, hey, is the largest angle across from the longest side length? Is the smallest angle across from the shortest side length? And so on. If you can get away with that, then you're probably on the right track. Did that kind of work? Yeah. Does this ring a bell? Ish? You did it.
I did it, I don't remember it.
So let's write down the last bit. And I know I've found all three parts that I was looking for. Okay. That eyelash stuck in my eye all day. You guys don't care. Okay. I don't want to do that one yet. Showing one. Oh, actually, you know what? No, I want to do, sorry, I want to do this one. I want to throw the ambiguous space out today. We'll do that. What do you think you should do first? Math. Very good. More specifically, what should you do?
I know what you need to
Draw what you need. Okay. Does something look off? What?
The A is 140 and the other is 5, and C, we don't know. Oh, the other C is bigger than 5.
So would this even work?
No.
No. That's what happens as you get to more of this in algebra 2. Sometimes they're going to throw stuff at you that you want to say, oh yeah, okay, whatever. But as soon as you draw it out, you look at it and go, wait a second. This can't work. The reason why this can't work is because that's obtuse, isn't it? Can there be any other angle in a triangle that is also obtuse if one of them is? No. Which means as soon as if you are ever given an obtuse angle and you have the side opposite, it better be the longest side length, because if the other one is, if this side length is longer, this means that this triangle does not exist. You can't make that triangle. It won't work. Okay? This is the idea of, we start to add a little bit more to the law of sine with you guys on this one. Okay? that make sense? So one of the tricks that I'll start to show you guys tomorrow about the idea of if it works, you get, there's a little checklist that we're gonna go through. But let's try one that does work. So you have angle B at 105, side B at 11, and little a at 5. Well, we're given an obtuse angle. Is the side opposite that longer than the other side? Then you're going to be okay. It's a quick little check that we'll leave with that for today. So we know that this is going to work. So when we draw our triangle, what angle is it forcing you to find first? A, yeah. It's forcing you to find angle A first because they're giving you the side opposite it. If it was, if it was the same idea if they had the side opposite C, it'd be forcing you to find angle C. Okay. Excuse me. So, I always like to circle what I am at. I like to circle what I know as my given information as far as my angle and the side opposite. And I start writing stuff out. Oop, I gotta find angle A, angle C, and side C. So we have the sine of buck 5 is to 11, as the sine of A is to 5. Let me show you a shortcut for this. Is there any reason why I should have to cross multiply both parts? No, there isn't. Because if I multiply by the 11 going towards the right, when I have to get the sine of A by itself, I'd have to divide by the 11 to bring it back. So anytime that you have to find an angle, you only have to move the one denominator. So what happens is you get this. 5 sine 105 over 11 is the sine of A. This is where knowing how to do the keystrokes in the calculator is key. Okay? This is where using the calculator is going to help you out. What I would do is this. I would type in fraction bar and I go 5 sine 105 over 11 and hit enter. That crummy decimal equals the sine of angle AA, thank you. So all I have to do then is, how do you undo sine? Remember the button to press?
The inverse.
Yeah, the second one, the inverse. So you hit second sine.
That's alpha.
Oh, thank you. Second sine of your answer. That way you don't have to worry about carrying over any decimals and rewriting stuff out. You utilize the calculator to do the work for you. And with any luck, then you get 2404, or 2604, excuse me. So that gives me my A at 2604, which means that I have 13104 so far. Subtract that from 180, you get 58, 48, 4896. And then I'll use the law of sines again with that newfound angle C with the given sets of B. And I go from there. And then I'll give you my other side. 8.59. And then just look back at your triangle real quick to see if it makes any sense. If those values seem to work out for each other, then you should be okay. Tomorrow's the fun stuff. I don't think we have enough time to do those. We can, but I don't know if you guys really like it. We okay on this? Vaguely remember that?
Yeah.
I can get the ones that I want first. I don't want to give you guys the ones that have all the fancy parts to them. Yeah, we don't need to get to the craziness yet. Actually, you know what? We'll do the area real quick too.
Wait, the area.
Yeah, you can find the area of triangle using this stuff too. So, because we have what, 15 minutes? Yeah, this is at 24, right? I always forget. All right, let's do that real quick. There's also this thing that we can do with this up. Makes more sense to do this today than it does tomorrow. There's also the thing you can do with this thing in the area of the triangle. This works out nicely if you have side, angle, side. When you have the a side angle side set up for a triangle, you can find the area of it. I wonder, did Seb show you guys this? I know I didn't show you this because I thought Seb might have showed you guys this little trick. So anytime you have side angle side in a triangle, if you have side angle side in a triangle, if you have side angle side in a triangle, what you can do is basically define the area of that triangle. Take 1/2 side times the sine of the angle. How fast is that? Anytime you have side angle side, to get the area of the triangle, 1/2 side times the sine of the angle in between, of the included angle. And that'll give you the area of the triangle. It's a nice thing to know, especially with ACTs and SAT stuff coming up, because the area of triangle stuff shows up on there. Instead of having to do 1/2 base times height, you have an irregular triangle. If you don't have a right, you can't draw altitude down and figure out the base and height stuff. If you have side angle side, you can do it. That's all that is. Pay no attention to all of these. Pay no attention to any of these. These are stupid. All you need to know is that if it is side angle side, if it is side angle side, I have 47, 2, and 3. Side angle side. All I have to do to find the area of that triangle is 1/2 side, sine of the angle in between. What's wrong, Vietmeyer?
Nothing.
You can use these calculators on the ACT.
Yeah, I was gonna say, if you have these calculators, you're set.
And that's the idea. A lot of times, because that table, that's why I keep showing you guys how to go back to table functions to see how things match up and how you can find zeros and all that kind of stuff. If you know how to do that, it's quick. Get there. All right.
No homework.
do that.
There's nothing wrong with that.
I can call it though.
I mean, he's gonna get mad at the way you put it, but yeah.
Why?
Let's just do those for right now. Then we'll build it out later. We'll do all the, we'll do what's called the ambiguous case tomorrow. To be honest with you, the ambiguous case looks like it's really, really awful with all the notes that they show you how to do it in the book. But I have a shortcut, and it works nicely. And you'll be very pleasantly surprised to learn that you already probably know how to do it.
When you get mad at that?
Yeah, give me a second.
You know how you do it?
Yes, ma'am. Oh, just show my desk. Unless, does anybody else need a cord? Kathleen's got a cord that you guys can use.